Okay, in this part, I would like to describe how can we find two vectors, whether they are perpendicular to each other. Perpendicular to each other, we can have something like orthogonal, okay, the term orthogonal. In vector point of view, we always use the term orthogonal instead of perpendicular, okay? So remember, for example, if two vectors are perpendicular to each other, we may have a concept like we usually multiply those two vectors together. It will become what? It will become 0. Why? Because of the dot product property. Okay, so what does it mean? Okay, think about if a vector I and vector j multiply together, it becomes 0. Why? Because in dot product, it equals to their two magnitudes multiplied together and also cosine theta. And because they are perpendicular to each other, so cosine theta becomes 0. Okay, cosine 90 degree becomes 0. Got it? Okay, so let's continue. Okay, so let's see, there are two things over here. Oh, what's the problem? Oh, it's weird. A break delay. Okay, so let's see here. Once again, I've told you that, for example, there are two vectors, which is a v vector and also w vector. Okay, if they multiply together, so it becomes 0. Okay, so let's see if we have the scalar method. For example, we have the position vector over here, like xi plus yj. Okay, so if it is the case, when we multiply together, so what will it be, the result? Okay, first of all, we found the slope of each vector. For example, here we go, we have the 3 times square root 3 I minus j, and this one we have a square root 3 I plus 9j. Okay, so first of all, we found the slope first. How can I find the slope? It's by y over x. Okay, that means it's rise over 1. So for this one, it's a negative 1 over over 3 over square root 3. So this is the slope of the e vector. And the next one, this one is a 9 over square root 3. So it's this one. If they are perpendicular to each other in the scalar method, we usually use the concept like these two slopes multiplied together equals to negative 1. Can you see that? Okay, so this is a concept you need to remember. Got it? Okay, how about for next part, for vector method, it's much easier, I think. You just use a dot product to multiply with each other, and then it should be equal to 0. Okay, let's check together. So if we are using dot product, so these two, the coefficient of I multiplied together, which is equal to 3 square root 3 dot square root 3, and plus, and these two, the coefficient of j multiplied together, so it's a negative 1 times 9. So that means this one is 9 minus 9, so we have 0. Okay, so this is the trick we are going to use for this. Got it? Okay, I don't think it's difficult, right? Okay, so in this part, I think a vector method is much better than the scalar method. You agree with that? Okay. Serious lagging. Another part, like, yeah, to determine whether two vectors are parallel to each other. Okay, let's see. Okay, first of all, if they are parallel, I have told you the concept that these two vectors can be scaled and then it becomes another. Okay, for example, P is equals to lambda times Q. Lambda is just a scalar factor, okay? Something like a real number like 2, 1.2, 0.5, okay? So if they are parallel, in vector we have this property. Okay, let's see, we have two vectors over here. P equals 1i plus negative 5j, and Q is negative 3 plus negative 3i plus 15j. Okay, here we go, is to take a look on the scalar method. If they are parallel to each other, let's find out the slope. The slope, that means this one is a y over x, rise over 1. So it's a negative 5 over 1 is the P, slope of P. And this one, 15 over negative 3 is the slope of Q. And you can see that for these two cases, both slopes are equal to each other. Okay, so then we can conclude that is slope of P equal is parallel to slope of Q. Got it? That means P and Q are parallel to each other. And how about the vector method? See whether you can find out the lambda. Okay, the lambda. For example, 1, negative 5 to the left side because it's P, and Q, negative 3, 15 is on the right side. Okay, think about this. How can I find the lambda? It's easy. 1 over negative 3, we have the lambda, and which is exactly equals to negative 5 over 15, also equals to negative 1 over 3. Got it? So if we can find a lambda that's suitable for this formula, then they are parallel to each other. Okay, so I don't think it's difficult. Remember, this is the scale, the length. Okay, the lambda is to scale the length. Got it? Okay, I think it's easy. Got it? If you can find out the lambda value, and then it's already fine. It's already approved. Okay, remember, you are going to use the vector formula to prove everything, because in the question, we are going to limit the method you use. Okay, we are going to let you to use vector instead of scalar in proving something, then you have no choice. Got it? Okay. It's about the cross product. For example, now we have vector A cross vector B. This one is not dot, okay? It's not dot, okay? It's a cross. We have two values. If A equals 0 or B equals 0, no need both. But cross together, of course, we have 0 vector. Otherwise, after the cross product, it doesn't mean it becomes a scalar. It becomes another vector pointing to another direction. I can say that this new vector pointing to the direction is a perpendicular to A and B. A perpendicular to A and B. But A and B no need to perpendicular to each other. Got it? But the resultant vector will be perpendicular to A and also perpendicular to B. Got it? Something like this, okay? Perpendicular to A and also perpendicular to B. So I call it cross product. Is one of the multiplication method that another version of multiplication apart from dot product. Remember, for cross product, when the vector cross the vector like A cross B, it will have the result that it produces the third vector also perpendicular to both A and B, to both original vector. Got it? I call it this vector. And what is the magnitude of this vector is easy. Just magnitude of A times magnitude of B, and then sine theta. Theta is the sandwich angle here and close angle here. And how about the vector n? Vector n, we call it normal vector. Okay, normal, that means perpendicular vector, perpendicular to both. Got it? And how can I get the normal vector out? I think it's easy because it's A cross B, right? So think about the hand here. A is something like here. Got it? A is something like here. Oh, this hand. Okay, when I cross it, okay? A, the first vector, cross another vector. Use your 4 fingers to cross it. And then the final vector will be the end vector, will be the result. That means the form, okay? The form will be the final vector. So A cross B, so the form will pointing outward. And if it is B cross A, once again, B cross A, the form will be pointing downward. B cross A, something like this one. Okay. B cross A, the form will be pointing downward. Got it? So remember, dot product, no matter A dot B or B dot A, they are the same. But for the cross product, they are different. A cross B, it doesn't equal to B cross A, but the vector is reversed. So we need to add the negative sign for the cross product. Got it? Okay. Finish this part. And remember, once again, this vector is a unit vector. Can you see that? We have the cap over here. This is a unit vector. And the magnitude is calculated by magnitude of A, magnitude of B, and sine theta. Okay? And what's more, so if it becomes IJK, so what will it be? Remember, one of the concepts I told you just now is that if those two vectors are parallel, they become 0. Okay, so A cross B, if those two vectors are parallel, because the angle between them is 0. So sine 0, it becomes 0. So for the cross product, if they are parallel, it's crossed together, it becomes 0. But for the dot product, if they are parallel, it's good, okay? It becomes magnitude times magnitude only, okay? And how about, so if this is the case, so I cross I, J cross J, K cross K also equals to 0. Remember, because of sine theta. How about if those are perpendicular cross together? Okay, for example, A cross B, and A and B are perpendicular to each other. So sine theta become 1. Okay, so let's see the concept. Because all of them are unit vector, right? So let's see. If A cross B, if these two vectors are perpendicular to each other, so it is sine 90 degrees, it becomes 1. And it only multiplies their magnitude of A, B together. Multiply their magnitudes together is okay. But for this case, I and J, the magnitude are 1 only. So I cross j, of course, is equal to magnitude of I is 1 times magnitude of j is 1 times the third vector, perpendicular vector is k. Got it? So it's easy. And j times k is also equal to I. K's cross I also equal to j, etc., etc. And once again, I've told you before that A cross B equals to negative B cross A. This is what I mentioned. And also, if we have the scalar multiplied to the cross product, the scalar can put anywhere. It's also okay. And put in front of A is okay. In front of B is also fine. Got it? And how about this one? A cross B plus C. So it equals to distributive law. Okay. A cross B plus A cross C. Got it? Yes, fill line matrix. We usually use matrix method to calculate this. Okay, and here we go. We have 3D vectors. A, the 3D vectors. B, if we multiply together, so multiply 1 by 1, and then we have 9 terms over here. Cross 1 by 1, we have 9 terms over here. Just eliminate what I told you is that I cross I is equals 0, J cross J equals 0, K cross K equals 0. So what we left is this one. Okay. Okay, it's difficult to remember the result like this. If we are going to remember, we should use matrix to remember, matrix method. For example, A cross B, we can write something like IJK at the top, and the middle is to be the first vector, and the bottom should be the second vector. Don't reverse the sequence, otherwise you cannot get the result properly. Okay, so if it is the case, so how can I make the tricks? First of all, if I would like to ask you to solve this, what method you're going to use? I think you have many different methods, right? But for example, I use this method. First, I high up this and this, I have this row, and I have the row including I have the column including I. So, and then over here, I use something like a small golden fish. What does it mean, small golden fish? Something like that. What's that? Okay, AY times BZ multiplied by AZ multiplied BY. Because we're going to have minus, so it seems like an I over here. So I call it small golden fish. So you have this one. And how about the next part? The next part, I high up the row in having the J. I have the column having the J. So what we left is this 4. So I use matrix method again. Small golden fish, AX multiplied by BZ, and then minus what? AZ multiplied by BX. Okay, and now write it down over here. But remember, because for this is at the lective region, so I must add the lective over here. Got it? And how about the last one? Last one is also the same. I high up the row including the K. I have the column including the K. So I use small golden fish again. AX multiplied by BY and minus, minus AY multiplied by BX. Okay, so I write down here. How about the psi? Because the K is at the positive region, so I just add it. It's okay. Got it? So I think it's very easy. I think it's just many of you have class mistakes. It's just over here. It's the lective psi here. Okay, many of you forget to replace it to negative sign. Got it? So remember this. Okay, so how can I use some tricks to help you to remember? Okay, it's not quite good, I think, but I would like to share something like, but before, I use a method like this sign, I call it negative, right? In Chinese, 就係負啦，咁咪當父親啦。父親一定有咩啊？ What is the letter here? 父親一定有。Yeah, very good. Yeah, every father should have this letter, okay? Yeah, but if you don't know why, so yeah, forget it. If you cannot use this method, forget it, okay? Every father should have this one. Otherwise, you cannot make you born, okay? Got it? Okay, so it's just a trick I use to remember. Yeah, if you think it's not quite proper, forget it. Okay, so let's see a real case on the calculation on the area. Okay, so let's see. How about A and B are both 2D? If it is 2D, so we can ignore the K, right? Ignore the K coefficient. But you also need to have 3 by 3 matrix. Don't remove this. Don't think about 2 by 2 matrix. If it is 2D, something like A can be A1I plus A2J, and B is also the same. So, and then the result is very easy. Because we don't have the coefficient of K, so this two should be 0. So A cross B, it becomes, yeah, first of all, yeah, when I high up this one, so A2 times 0 minus 0 times A2, it becomes 0I, right? And J also the same, A1 times 0 minus 0 times B1 is also 0, right? So that means we only have the answer, it's not 0, it's just a K. It's A1 times B2 minus, okay, A2 minus B times B1. So it becomes this. So finally, we have 0I minus 0J. So we have 0, 0 here. And then the last one is to be A1, B2 here minus A2, B1 here, K. Got it? Is it clear? Okay, so what is the usage for this? Yeah, we usually use this to calculate the area of the triangle if we do have the angle here. Okay, because let's see here, how can we find out the area of a triangle is equal to half AB side, the angle between them. Okay, 1/2 AB, yeah, side series angle. Got it? So if I extract the 1/2 out, AB sine theta is equals to what? Is equals to A cross B. But we are no need to have the vector, right? So I add the magnitude sign to net you to only concern about the magnitude without concern about the vector direction. Got it? So that means if you would like to find out two vectors, the angle between two vectors, okay? Sorry, the area between two vectors, you can simply use half A cross B and find out the magnitude, and then you can have the answer. Got it? Okay, because A cross B equals to A magnitude, B magnitude, like this one, A magnitude, B magnitude, and sine the angle between them. Got it? So remember this, for the area of the triangle. How about the area of the parallelogram? Because the parallelogram consists of two exactly the same triangle putting together. Got it? So that means you no need to use the half, which is exactly equals to the magnitude of A cross B. Okay, it's easy. Okay, finish. Very easy. So take a look on these two. Okay, it's pretty easy. So once again, if we are focusing on the magnitude of A cross B, that means we can ignore the normal vector. Got it? Okay, this one over 2, and then we have the triangle. Easy. Let's start to work out the example 4. First of all is that we have the A vector here, and then 3D vector, B vector, another one, also 3D vector. And you're asked about the A cross B. I think it's pretty easy, right? First of all, put the A at the middle column, middle row. Over here, middle row, okay? Just by here, and put the B another way around, so like this one. Okay, and then what you're going to do is that you hide up something, so I draw something over here to help you to have a faster copying. Okay, first of all, we're going to have the I, so it should be 2 times 3 here, and minus and then -1 times -1. Okay, so it becomes O. O is cubed. Y becomes -8. Okay. It should be, this 6 minus 1, so it should be 5. Okay, so it should be 5 here. Okay, cross out this. Okay. Oh, yeah, I think I have put to the wrong location over here. Okay, another one is that because the symbol over here is plus sign, so that means we're going to have plus sign here. Got it? Easy. Okay, how about the next one? We are going to high up is that, sorry. Oh, what's the problem? One times -1. -8, no problem. Oh, sorry, it's K, sorry. Yes, I'm wrong. Sorry, it's my fault. It's my fault. This is K. Yeah, really sorry. Yes. What I'm doing. What I'm doing. Sorry. Okay. I'm crazy. Yeah, I should, because I'm going to do the I. Okay, so I should Okay, what's the problem for my highlight? I should highlight this. What's the problem? Okay, I should highlight this one. How can I highlight others? Okay, so it should be this one. 1 minus, okay, 3 times 3. Okay, so it's elective egg is correct. Okay, sorry. Yeah, I haven't eaten the lunch, maybe. Okay, this one is here, remember. And yeah, because the region just now is a positive region, so it should be positive sign here. So that means it's a positive negative x, so it should still be negative x. Got it? And how about next one? Once again, I multiply this one, 2 times -1, and minus 3 times -1. Okay? So, yeah, that means it becomes 1. Okay, but we have the, because now it's the negative region, so it becomes this. We add the negative sign here. Okay, how about the last region? For the last region, it should be positive again. Okay, so I point it here. So last one, I think it's easy. Just highlight the, I have the case, so it should be 2 times 3. And then minus. Yeah, negative 1 times -1, so it should be 5. Okay, sorry that just now I'm silly. Okay, and then for part B, find a unit vector which is perpendicular to both A and B. Because of the property of the, the cross product, and then you can already find out the vector perpendicular to A and B. So I just use A cross B to find out the n vector. Okay, after you find out this, got it? So it should be this result, right? But it's not unit vector. It's not unit vector. Okay, so what you are going to do is that you need to put this unit vector over the magnitude of this one. Okay, so first of all, you calculate the magnitude of this vector first. So maybe I call A cross B the resultant vector is the n vector. So I calculate the magnitude of the n vector. So it should be x squared plus 1 squared plus 5 squared to get this. Okay, so the magnitude is 3 square root 10. And so the unit vector is pretty easy. So that means you have the unit vector like this one, and then we have the cap above, right? The cap above, which should be equals to what? Equal to this vector, okay, over this one. Is already fine. Okay, that means I have a 1 over, okay, and I just copy this one, 3 square root 10, and multiply by the unit vector over here. Sorry, by this one, negative 8, comma, and then -1, and then positive 5. And that's all. Okay, this is a unit vector. Got it? And yeah, and I think this is fine. And finally, for part C, find the area of the parallelogram formed by A and B. Just now I've told you that to find the parallelogram formed by A and B is just get the magnitude of A cross B is okay. So you are getting the magnitude of these vector. So it's exactly equals to 3 stroke 10. And finally, you give the unit. This should be the square unit. Okay, don't forget this one, or we will deduct mark from you. Okay, easy, right? Okay, finish. And then another example. You are asked to find out the area of triangle ABC, where A equals to 1, 1, 1, coordinate 1, 1, 1, B coordinate 3, 0, 2, and the third one coordinate 4, 5, and -1. Okay, so let's see these two diagram. And okay, think about this. I mark 1, 1, 1 over here. I mark 3, 0, 2 over here. And I mark 4, 5, -1 over here. Okay, this is the point C. I forget to add the C equals over here. Okay. Now, what you are going to do is that you need to mark out, you need to convert them into vector. Okay, convert them into vector if we are going to use vector method. So we need to add the extra O over here to form a position vector. So we have OA, OB, or OC over here. Got it? Okay, so if it is the case, and after I mark this, so we have OA, OB, OC. And now I would like to find the area of triangle. We have the formula like here. Okay, half, this one. So how can I make use of this? Think about this. How can I make use of this? We are going to find out the vector AB. Yeah, by the similar procedure, we're going to find out vector AB and find out vector AC. And I call it this one. And yeah, if this is the case, so this is a vector A, this is vector B, something like that. So we can find out the area. Got it? So how can I get the AB? Okay, it's easy. AB vector, I've told you that is a O, the letter vector minus the O former letter, okay? So that means which is equals to OB vector minus this one, OA vector. It's already done. And then we have the AB vector. Got it? So that means you have 3, 2, 3, 0, 2 vector minus 1, 1, 1 vector. So the answer should be 2, -1, 1. And how about AC? Same before. That means it's OC minus OA, right? So I write down the same thing. It's an OC minus OA. Okay, so we have this one minus this one. Got it? So this is the AC. And then what we're going to do is that we're going to half the magnitude of this one. So to begin with, we use the cross product to multiply these two vectors first. So this is AB cross AC. So we do this, and then when we cross it together, I don't want to do the matrix anymore, and I give you the answer like here. Okay, after that, what you need to do is that we are going to have half the magnitude of this vector to calculate the result. So the result is like this. Got it? How can I form 174? Okay, I think it's very easy. 174 by equals to this one, -2 squared. plus this one 7, positive 7 square, and plus the final one is 11 square. And finally, we need to square root this. Okay, so got it? Easy. Okay, finish for this question. You think it's easy, right? Okay, let's work about on the application of cross product. Okay, first of all, when do we need to use the cross product? Okay, think about this. In many cases, we use it when we take a look on the operation of moment. Moment is something like F times D. What does it mean? For example, if you would like to rotate something, okay, you need to calculate the moment. The moment, that means whether the rotation is more willing to do. If the moment value is larger, that means it's more willing to rotate. Got it? Okay, first of all, for example, we have something like we have the moment arm D over here, and then we have a force. It's a perpendicular moment arm D, and for example, we have the wheel moment arm over here. Okay, and I apply the force over here. And we have the angle between, it's called the alpha. Okay, so how about the perpendicular distance? It should be the D here. How can I find out the perpendicular distance? I think it's pretty easy, just R sine alpha, and then you can find this. Why is not this smaller angle? In fact, it's the same. Once again, the D can be found by R sine 100 minus, R sine 180 minus alpha. And then we can get the D, right? But I can tell you that it's a general mathematics, sine 180 minus alpha equals to sine alpha. Got it? Easy. So in order to find the moment, we need to do is that the F value and then times the D, right? The D can be represented by R sine alpha. Can you see that? F magnitude, R magnitude, sine alpha. It exactly equals to what? The magnitude of F cross R. F cross R. Got it? And because the final one, I would like to let you know the final one is also the vector. Okay, it's pointing upward. It's along the axis, So I still keep the vector property. I don't want to have the scalar. I still keep the vector property. So I put the vector M here along the axis. Got it? So it's a little bit different from your physics. When something is rotating, at the axis of rotation, we have the vector coming here. If this vector is positive value, that means it's in the something like anti-clockwise direction. Okay, I'll tell you later on of this. Okay, so let's see an example of this. Remember, the D can be represented by R magnitude times sine alpha. So which can be modeled by cross product. Okay, so let's see this example. Okay, here we go. We have the pivot. Okay, the pivot point A, and then this is the D, 6 meter, and I apply the force over here, which is F equals 500 Newton. Okay, this is what we call bent bar at 30 degrees. Now, when the force applied to the end, find the moment of F about A. So, what's that? What's that? Okay, think about this. When I apply the force over here, think about the moment arm. I can think about this one should be the R, right? Should be the R. And then this angle should be 60 degrees, right? So if it is the case, and how about the angle over here? It should be the alpha. Got it? It should be the alpha. So what I would like to do is that, how can it rotate? It rotates like this, okay? It rotates like this. Okay, think about this. So first of all, we have the vector direction is the result. It's a pointing along the axis of rotation. So that means this vector is pointing to the direction of rotation. So which is at the A. At the A, that means at this web point. Okay, at this web point. So let's calculate this. First of all, I think about this F should be 500, but this is a 2D. So when I write down the expression of the vector F, I write down is that 500 cosine 30 degrees is pointing to the x-axis, x direction, horizontal direction. So I write down here. And how about, the y-axis? Because the 500 is pointing downward, and if it is x, upward is y. So here I have a 500, I call it negative 500, and then sine 30 degrees. That means it's pointing downward, okay? And finally, we have the set. Because this one is 2D, we don't have the set direction, okay? So I set the set direction equals 0 here. Got it? Okay. And how about the R vector? R vector is easy because this one is horizontally is 6, so I call it 6i. And vertically is 2, so I call it 2j. And we don't have set component, so that means it's 0. Okay. Then what you need to do is that you need to find the vector of rotation. Vector of rotation is use the moment cross product. Okay, we set something like that, and then finally we have this one multiplied by 2 minus this one multiplied by 6, and then finally we attach the k vector over here, so we are getting the result 2366k. Got it? Okay, so here we go. Got it. So let's see the side. Okay, so once again, think about this first. In fact, for both methods, we can also calculate the same results. But for the vector method, we do have the vector k over here. And why I know that the rotation? Because of the psi. Got it? Because of the psi. Yeah, let's see here. What I mentioned is that because this is positive, okay, so that means they are pointing downward. But how can I know that whether it's pointing downward or upward? Because I put the F cross R. F cross R. Okay, so by one thing called right-hand grid rule, F cross R. So let's see. F is here. Okay, it's difficult to perform. F is here and then R is here. Got it? F cross R. So it's pointing downward. Okay, the form is pointing downward. Got it? F cross R. How about R cross F? Yeah. Yeah, sorry, this one is R cross F. This one is R cross F. R cross F is pointing downward. If F cross R is pointing upward, so yeah, sorry, this one is R cross F. Because when I put the R over here, okay, let's see here. Yeah, so it should be upward. So, sorry. Let's see here. Let me guide you like annotation. This one. Because our vector is doing something like this. Okay, so if it is a case, so this one is also our vector, right? So when you R cross F is like this. R cross F. Okay. So the axis on A is pointing downward. Okay, pointing downward. How can we represent downward? It's something like a cross. That means pointing downward. Okay. How about F cross R is pointing upward? Okay, F is here. Oops, sorry, it's difficult to use the hand. Yes, F cross R. 亂做嘢。亂咗。Yeah, R cross F is this one, and then F cross R. Yes, this is F cross R. It's pointing upward. Okay, F cross R is pointing upward. And that's it. Pointing upward, how can we represent? It's represented by a dot. Okay, that means it's pointing upward. So because we call this one is out of the paper or into the paper. Okay, so let's see. This one is into paper. Okay, for the cross. And then this one pointing upward, so it's out of the paper. Then, okay, so just now I calculated 2366. Okay, 2366. So it is pointing upward. Okay, 66K over here. That means it's pointing upward, not downward. So it's misleading you. Okay. That's it. And how about the scalar method? The scalar method is you just find out the alpha over here. Okay, and then use the F magnitude and the, yeah, this one is 60 and this one is tangent 6 over 2, and then we have this angle. So the enclosed angle is a 131.57, and then F is the 500, and D is the R. So it should be by using Pythagoras theorem, 2 square plus 6 square, and then square root this, and then sine the average angle, and then we have the results through 366 as well. Okay, this is the moment. Got it? Okay, so that's all for this example. And once again, why we need to use this? Why we need to use vector to perform the calculation of moment? Because of the future thing is that the concept of 3D world. Okay, this one is applying on the 2D scale, but how about if it becomes 3D? We need to do this. Got it? We need to use vector to perform. Okay, so finish. Okay, so please download the file from the web, or I send to the chat room for you to do this. Oh, I need to send to all, right? Okay, remember the plus is my name. It's a Frankie. Capital letter F, small letter R-A-N-K-I-E. And I need to upload to the web as well. So, okay, please wait a moment. Okay. Okay, all together, check this out. Go to my web. to download if you cannot get from the chat room. It's over assignment. Yeah, it's over here. Can you see that? We have the dot cross product. Okay, so you click on this. Got it? Okay, try it now. Once again, we have 1, 2, 3, 4, 5 parts. Okay, including the projection. Okay, so I think I give you 5 minutes for each one. Again, 5 minutes for each part. Okay, so start the timer again. Okay, do it now. No music. Remember, they are with respect to O. We have a 3 position record, so that means this one should be the OA. Okay. And next one is OB, and the third one is OC. Okay, it's easy. Hello, everybody. Okay, so therefore this first of all, you formulate the AB vector and AC vector first. Okay, AB vector is by OB minus OA to form this. I think it's easy, right? OB minus OA to form this. How about AC? This one is OC minus OA to form this. Got it? And after that, we do the dot product and cross product. I think it's pretty easy. All of you can do that, right? So another 4 minutes, 5 minutes maybe. Yeah, 4 minutes, I think it's fine. It's coming. You are asked to calculate the side. The theta is angle BAC. Okay. Okay, continue. Okay, so BAC, that means A is here. For example, I don't know, maybe B is here. Okay, B maybe here. And just simple. Just average 3 direction, okay? And then so if we have A, B, dot AC or cross, okay? So you are doing something like that. Okay, so the angle over here should be like here. This is the angle theta. Okay. Then you need to work on some of the cross product, right? Okay, let me give you the answer of part B. I think it's super easy. It's like that. Okay. Based on the cross product, find out the magnitude, and then over magnitude of AB and AC, and then you can find out the sine theta, sine this angle. Okay, so here we go for, I think 4 minutes is okay for the value of cosine. This one. Get oil. Okay, for cosine angle, I think you need to use this cosine law, right? Otherwise, you cannot write this. So let's see for cosine law. No, cosine law is a dot product. So I'm sorry. I'm hungry, in fact. Okay, so get back. Okay, use dot product to calculate this. Okay, the next one I think is to be the exact area of triangle ABC. To find the area, I think you need to use cross product to work out this. So I don't think it's difficult. So I think I can give you also 4 minutes to work out this. 4 minutes. Okay, let's get started. I think the last part is much difficult because the length of projection, because it's involved the previous chapter 6, previous chapter question. Okay, finish. And then the answer is very easy. I think all of you are correct for this, right? But some of you may forget to have the square unit over here, isn't it? Okay, so you should have this. Got it? Okay, last one, another, I think 3 minutes is okay. Why? Because the length of projection of AB in the direction of AC, I think I need to remind you. Okay, so we have the general formula, it's very easy. It's a magnitude of AB dot AC over AC is okay. Okay, so let me guide you back. Yeah, it's this page. The projection of vector on another vector. Yeah, it should be the length should be calculated by because it's A on B. Okay, project A on B, so it should be A dot B magnitude. Sorry, A dot B absolute sign, absolute value over the magnitude of B. Once again, A dot B absolute sign over the magnitude of B. So recognize this two stroke is not magnitude, it's an absolute sign over here. But for the lower part, this is the magnitude. Got it? So by making use of this, and then you can calculate the answer, I think. Okay, try this. Now you are going to calculate this one, and you base on this formula. Okay. Finally, we have this. Once again, I think all of you can calculate the answer properly, right? But you forget to write down the units over here. Okay, because for length, for area, for volume, you should have unit, square unit, or cube unit. Okay, so I think it's pretty good that we can finish both the chapters I would like to teach you and also the classroom exercise. Okay, thanks for coming, and I think it's almost the end, but beware, it seems that biomedical for attendance taking, once again, is that the Zoom will automatically take your attendance when you use Link account to log in. Okay, I think it's not a problem. Okay, and so what's more is that the biomedical engineering society would like to have promotion over here, right?